Hello, I'm Jens Krinke from UCL, and I'm going to present our work on whether code reviews are really helpful in removing coding violations. This is joint work with all my co-authors who were at UCL at the time of this work. We know that coding style matters very much in code review, but Shelley and Bird in 2013 pointed out that a major component and aim of code review is to improve code readability. A year later, there has been an investigation why patches were rejected after code review. And 16% of the patches that have been rejected in the Eclipse and Mozilla projects were actually rejected because of coding style issues. So we investigated coding violations during code review. We wanted to know how many coding violations are introduced into projects despite code review, what kinds of convention violations are addressed during code review, and do convention violations delay the code review process. In this presentation, I'm only going to look at the first two research questions. There are two major tools for our experiments. Our dataset that we use is the open source dataset of code review data called CROP, and we took 4 Java projects from that dataset. We use checkstyle to check for violations of the Java coding conventions. There are 62 types on convention violations that can be detected by checkstyle. We had to modify this configuration slightly as our projects have small deviations from the Java coding conventions. There's one problem that is often overlooked when code reviews are studied. That is rebasing. Rebasing happens when a system is further developed while a change is under code review. Here's an example. Somebody has created a change and submitted it for code review. Well, the code review has suggested some changes which our developer has implemented and resubmitted the patch for another iteration. However, during the code review, further changes have been applied to the system. At the end of the review, the change must be rebased. That means the change is based on the current version of the system before it can be accepted and merged into the main branch. Last year at SCAM, this phenomenon has been studied, and it became clear that rebasing happens very, very often. For example, the eGet project in our dataset has 4,500 reviews where the patch has been finally merged into the system. 2,400 of those had to be rebased. And in more than 1,000, the rebasing affected the same files that were actually also affected by the change under review. So we cannot just compare the violations in the system after the initial patch and the violations in the system after the final accepted patch. So we have a more complex setup. We have to investigate what are the convention violations that appear through the initial patch, and we also have to investigate what are the convention violations that appear in the final merged patch. To do that, we extract all the convention violations before the initial patch is applied and after the initial patch is applied. And we extract the convention violations that appear by comparing the before and after list. We do the same for the final patch. We compare the convention violations before and after the final patch has been applied. We then compare the two lists. A review is considered in the change category if the violations introduced in the initial patch differ from the violations introduced in the final patch. A review is in the improved category when a violation was introduced in the initial patch but is no longer introduced in the final patch. It disappeared during the code review. Let's have a look at the results. This is the histogram comparing the number of violations that appear through the first patch, the initial patch, and the number of violations that appear because of the final patch. And we can see for all the categories we are looking at, the number of violations in the final patch is larger than the violations in the initial patch. That doesn't mean that code review actually makes things worse, because we can observe that the final patch is usually larger than the initial patch. There's one exception, which is trailing whitespace. Only for trailing whitespace, the final patch usually has fewer violations of this coding convention. Trailing whitespace is a specific regular expression that is checked for, and in a normal configuration there is no other check using a regular expression. To answer the second research question, we did a large-scale manual investigation. Therefore, we investigate the code review comments, meaning the inline comments and the general comments. And the question the manual investigator wanted to ask, whether a violation is actually discussed during the review. To do so, two authors investigated each review in which a violation disappeared in the end, in the final patch. That means it belongs to the improved category. If there was a conflict, that conflict has been resolved in a discussion session at the end to resolve all conflicts. Let's have a look at the research question results. This histogram shows per category of convention violations the number of reviews in which this category of violation disappeared, and in black we're showing the number where we couldn't find evidence of a discussion or flagging of this violation during the code review, and the gray bars show the number of reviews in which we could find evidence of a discussion or flagging during the code review of this specific convention violation. From the histogram, we can see that in the majority of the cases in which a convention violation of a specific category was introduced in the initial patch, but is no longer in the final patch, meaning it has disappeared, was not due to reviewers flagging the issue. More specifically, for 24 out of the 62 convention violation types that CheckSty can detect, not a single violation was flagged by a reviewer at all. Again, trailing whitespace is a special case. It was flagged by most reviewers, and it also most often disappeared without being flagged. And then for JGit and EGit, we have another pattern. The second largest number of flagged and disappearing convention violations belongs to the block category. In 2015, EGit and JGit removed a deviation from the normally accepted coding conventions. Now let's have a look at what's going on with this trailing whitespace. There are explicit conventions for trailing whitespace, meaning that it's not allowed. And there is specific advice in the Eclipse projects on how to remove it automatically. However, it remains the violation that is most often flagged and fixed. It took us a while to figure out why that is the case, why trailing whitespace is such an outlier. This became apparent when looking at the specific comments that flag trailing whitespace. The Gerrit interface presenting code review actually shows trailing whitespace in deep red. So it's easy for a code review to spot trailing whitespace. Therefore, we have many more instances in which a trailing whitespace is flagged by a reviewer and also then removed because of that comment. So, what are the general results and what can we take away from our investigation? From the eGit and JGit example, we see that deviations from generally accepted coding conventions can lead to confusion and unnecessary discussions during code review. From our overall study, we can see that humans are neither effective nor consistent in preventing the introduction of convention violations. So overall, in addition to the research question 3 that we didn't discuss in this presentation, convention violations cause unnecessary costs during code review. Costs caused by reviewers flagging the issues and then the authors removing those issues. And of course, the reviewers just checking for convention violations. That's wasted time that an automated tool could take over. So this leads to the final controversial 2 questions. Should deviations from generally accepted coding conventions be disallowed in general? And should humans check for coding conventions at all? Wouldn't their time be better invested in something else? Thank you very much for listening, and I'm happy to answer your questions now.